Assalamu alaikum and hi. Can you try to flip your phone end over end like this? How many type of rotation can you make?
The phone has three axes which it can rotate. There's the long axis which has the maximum moment of inertia. That means it requires the most torque to accelerate it in that direction. And there's the short axis which has the least moment of inertia. And that requires the least torque to accelerate it in that direction. And there is intermediate axis which has a moment of inertia in between the long and the short axis.
Well, the intermediate axis theorem says that if you try to flip any object along its intermediate axis, it will not maintain that rotation. It will rotate in any of the other direction. And that is true. So why does this happen?
Well, the mathematics is kinda complicated, but it's similar to the mathematics of a rigid pendulum. So, if you're flipping the phone along its long axis or its short axis, the phone behaves just like this pendulum. Will cause it simply to go back to where it was before. But if you're flipping it along its intermediate axis, it's like you're trying to balance the pendulum on its end, and it's very unstable, and any slight of disturbance may cause it to exponentially increase.
So that's why you cannot just flip your phone along its intermediate axis without it spinning along short or long axis. And we call this phenomenon intermediate axis theorem or tennis racket theorem or Cherenkov effect. Why tennis racket? Well, the tennis racket is a perfect example to show this phenomenon. And why Jenny Bekoff? Who is this guy? In 1985, cosmonaut Vladimir Janibekov was in charge to save the Soviet space station Salyut 7, which had a completely shut down. And the Russians made a movie out of it in 2017, which is called Salyut 7.
And after rescuing the space station, when Chenebekov unpacked supplies sent up from Earth, he noticed something strange. As the wingnut spun off the bolt, the wingnut maintained its orientation for a short time. And then it flipped 180 degrees. And a few seconds later, it flipped back. And it continued flipping back and forth at regular intervals. This motion wasn't caused by force or torque applied to the wingnut. There were none. And yet, it kept flipping. It was strange and bizarre phenomenon, and that Russians kept secret for 10 years. However, a team of mathematicians independently noticed the effect in a tennis racket and elucidated the math behind it. They published their paper, The Twisting Tennis Racket, 6 years later. The history of this effect's complicated discovery is why the intermediate axis theorem goes by these two other names. Now that we know what it's called and where it came from. That's all from me. Thank you very much.